Alright, ladies and gentlemen, in today's video, what we're going to be discussing are radical equations. A radical equation is simply an equation where the variable that we're solving for happens to be underneath the square root symbol, or the cube root, or whatever the case may be. Mostly it's going to be either square root or cube root for our purposes. Now, because of the fact that it is a square root value, that means we have to know how to undo it. And that's kind of what we're being shown here on this slide, is that whatever the value here is, as far as this number, we're going to undo it by squaring it. Like the square root of x squared is just x. The cube root of x to the third power will be x. We're just going to raise the radical to whatever the power of the root is, and that is how we're going to undo it. So there's nothing really new. Now, what we're going to be doing here, very similar to when we did absolute value equations, is we would isolate the square root symbol. Well, this is no different. We must isolate the radical symbol before we can try squaring something or cubing something in order to eliminate the square root symbol. Okay? Now, the rest of these things are just going to kind of be, well, what do we need to do to finish off? Because sometimes when we work these things out, they give us more work than it might seem initially, but as long as we stick to our algebra rules, with our option operations or anything like that, we should be okay. Now, just like with the rational equations, occasionally the math is going to work out where it's going to give us something that, according to the math, looks like it should be a solution, but if we substitute that number back into the problem, unfortunately it doesn't really work out. Okay? So we do need to check for any extraneous solutions. So here's our first example. The cube root of 6x minus 7 divided by 4 minus 5 is equal to a negative 6. So we're going to begin by kind of isolating the radical symbol, just like what we would normally do. Get rid of the addition first, and then we'll take care of the division with the 4. So those are opposites and cancel, and here negative 6 plus 5 is a negative 1. So here I'm going to get the cube root of 6x minus 7 over 4. Since the 4 is being divided in the problem to the opposite, and multiply both sides by 4 to simplify it to 1, so that'll give me the cube root of 6x minus 7 to be equal to 4. Now at this point we have the radical symbol isolated. So this is where we're going to do it. Since this is a cube root, I'm going to cube both sides of the equation, and the cube root cancel each other out, which will be 6x minus 7 to be equal to negative 64. Negative times negative times negative is a negative number. Now we're going to just solve the rest of this pretty much like normal. Move the 7 over through addition, and I get 6x is equal to negative 57. Divide both sides by 6, and I'm going to get x is equal to negative 9.5. Now that I know what the value of the solution is supposed to be, well, we do have to check. Now, because we only have one solution here, we really shouldn't have to check to see if it's extraneous, but we're going to go ahead and do it just to be on the same side. So the cube root, so 6 times negative 9.5 minus 7 over 4 minus 5 equals negative 6. Let's see, does it all work out? So underneath the radical, 6 times negative 9.5 minus 7, that's going to give me a cube root of negative 64 over 4 minus 5 over 6. Now, some of you may be wondering, okay, well, hey, I have a negative number underneath the radical here. And in this case, it's actually okay to have a negative number where that 64 is, because of the fact that the value of the root is an odd number. When the root power is an odd real number, unlike if I try to do the square root of a negative number. So the cube root of negative 64 is negative 4. And I put that over 4 minus 5 equals negative 6. So this gives me negative 1 minus 5. And so negative 6 equals negative 6. So we know that negative 9.5 is a good solution and it's not an extraneous one. Now here, looking at this particular problem, I can let you know this one is going to get a little hairy with the algebra. So if you're at all unsure, please pause, rewind, write down the question if you're not sure about anything, and bring it to me in class when you see me next. But here, what is happening, because we have two radical portions of the equation, we have one on the left side and one on the right side. Well, the one on the left side is already isolated, which is one of the things that we're told to do first, which is isolate the square root, or isolate the radical, I should say. So because it's already isolated, we're going to undo it, but that means we have to square both sides. So on the left side, the square root of 3x squared is just going to give me 3x. Now on the right side, unfortunately, this is an expression that we now have to square. So I have the square root of x minus 3 plus 3 times the square root of x minus 3 plus 3. And this is where, on the right side, you can see, well, this is going to have to be FOIL. And that's where some of us might struggle a little bit with the algebra. But that's okay. Just stick with me and I'll walk you through it. Now here, the first terms, the radical x minus 3 times radical x minus 3, I'm going to just kind of do that over here on the side. That is saying square root of x minus 3 times itself is saying square. So that's just going to work out to be x minus 3. Okay, so that one's not really too bad. So square root of x minus 3 times the square root of x minus 3 is just x minus 3. Now I have to take that same thing and multiply it to the 3 here. Well, the 3 is a whole number, and the square root of x minus 3, we have no idea what that's going to be. So I'm going to just say plus 3 times the square root of x minus 3. Same thing with the inner terms, get the exact same thing. 3 plus the square root of x minus 3. And then finally the last terms together give me a positive 9. So hopefully I didn't lose you, but if I did, again, write down where you got lost and bring in your work, and I'll try to walk you through it at a little bit more slow pace one-on-one. As with any time we FOIL something, the two terms in the middle are always going to be odd terms. But if you notice, I also have a whole number here, well, an integer here, 3, and an integer here of 9 that can combine. So I'm going to get x plus 6 between the negative 3 and the positive 9. And the two terms that were here in the middle, that's going to give me a positive 6 radical x minus 3. The radical doesn't change. It's just the number in front of it that gets added together. So now we have the square root symbol still on the right side of the equation. We have to isolate. So I'm going to take the x and 6 and move them over here. So minus x minus 6. And that's going to give me 2x minus 6 to be equal to 6 times the square root of x minus 3. Now at this point we have a couple of options. What we're asked to do to solve these problems is to isolate the square root. To really isolate the square root, I'm going to be able to divide by 6. But if I divide by 6 on the left side, I'm going to wind up with a fraction of 1/3 x. And fractions, as we know, are not our best friends. So even though the 6 is still with the square root on the right side, it's not isolated, we can still square at this point the right side and the left side. And it'll all work out to be the same. We'll just wind up with slightly bigger numbers, but those are okay. We would prefer slightly bigger whole numbers to fractions whenever possible. So on the left side, 2x minus 6 squared is going to be 2x minus 6 times 2x minus 6. And And on the right side, 6 squared is 36, and the square root of x minus 3 squared is x minus 3. Now, I'm putting it in parentheses because the 6, so let's get multiplied to it for 36 now. And on the left side, let's go ahead and FOIL that out, and that's going to give me 4x minus 12x, or 4x squared, got that, minus 12x minus 12x minus, plus 36. See how easy it is sometimes to lose your signs. And on the right side, I'm going to get 36x minus 108. So simplify everything on your left side. Equal sign, and it's going to be 4x squared minus 24x plus 36 to be equal to 36x minus 108. Now, the largest term is the 4x squared. So that means to put it in standard form, we're going to move everything over there. I'm going to take this 36 and move it over, and this 108. It over to the right side, so minus 36x plus the 108 here. And I'm about at a room at the bottom here, so I'm going to write it up here. And that's going to give me 4x squared. The negative 24 and the negative 36 are going to give me negative 60x and plus 144 to be equal to 0. So now it's in standard form. All right, so now we're at a point where we've manipulated the equation through several operations now to get a quadratic expression, 4x squared and so on. And based on the fact that it's quadratic, now we can see, well, can we factor it? And the nice thing is that we can. And even nicer is that everything has a common factor of 4. So I'm going to factor 4 out of everything, and that's going to give me x squared minus 15x plus, what was that number, 36 to be equal to 0. So, break up the quadratic inside those parentheses, and that's going to give me an x here and an x here. This is a positive number, so, and this is a negative number, so that means that both of these have to be negative, so that when I multiply them together, I get a positive, like C term, that I can add together, making it 15. So that means that the two factors of 36 that reduce those numbers are going to be 12 and 3. So now that I have my two factors, remember the 4 left because it doesn't have an x on it, it's not a factor. So now I have x minus 12 to be equal to 0, x minus 3 to be equal to 0. So x equals a positive 12 and x equals a positive 3. Okay? So those are the two solutions. Now, because we have two solutions, which normally we may not get one of those for a radical equation. It's okay to get two solutions for a quadratic, but not always necessarily for a radical. So we have to check to see, do both of these actually work and not give me an extraneous value. So let's start with the bigger number. Let's start with the 12. So if I say the square root of 3 times 12 to be equal to the square root of 12 minus 3 plus 3, and see what we get. Well, here on the left side, we're going to get the square root of 36, and here we're going to get the square root of 9 plus 3, so this is 6 will be equal to 3 plus 3, so 6 is equal to 6. So that worked out. The 12 is a good solution. So now let's check 3. So, same thing, 3 times 3 equals the square root of 3 minus 3 is 3. So I get the square root of 9 equals, well, the square root of 0 is just 0, so we're just going to put that 3 over there. So now the square root of 9 is 3, and 3, and that worked out. Now, when we're checking these, we're only really concerned about the principal values. You notice when I took the square root of 36, I didn't say plus or minus the 6. So when I took the square root of 9, I didn't say plus or minus 3. When we're checking these, we're really only concerned about the principal values. Okay, so that's why I didn't do both together. Now here's going to be our last example, and since this is our last example and we haven't seen anything that gives us an extraneous root, guess what we're going to get here. Now this one again is going to give us a little bit of work to do with the algebra, but it's not going to be something crazy to do as long as you kind of be methodical, take time, don't rush. Now, the first thing we need to do is isolate the square root symbol. So in order to do that, I'm going to take this x and move it to the other side. And so here goes 0, here I get negative x plus 2. So this is going to give me negative x plus 2 on the right side and the square root of 2x plus 31 on the left side. Well, at this point, we have the square root isolated, so that means time to square everything, so we can undo it. On the left side, we're going to just wind up with 2x plus 31, because if I square root, they undo each other. On the left side, you can see we're squaring an expression, so x minus negative x plus 2 squared, 2 is negative x plus 2, like that, squared. So 2x plus 31 on the left side is just hanging out right now, nothing really to do. Let's spoil the stuff on the right. Negative x times negative x gives me positive x squared. Negative x times positive 2 is negative 2x for both of the inner terms. And 2 times 2 is 4. Combine these like terms, and I'm going to get x squared minus 4x minus plus 4. So now the largest term is the x squared on the right side, so that means take everything and move it to that side. Minus 2x here, minus 31 here. Okay, and now everything on the left is 0, and I'm going to get x squared minus 6x minus 27. So now we have a quadratic expression in standard form that we can factor. So let's factor. The factors of 27, one has to be positive, one has to be negative, because when I multiply them together, it can be negative. And because this is negative, the bigger of the two numbers needs to be negative. So x minus 9 and x plus 3 are what we're going to be using for those two particular factors. Set each factor equal to 0. And I'm going to get x to be equal to a positive 9 and x to be equal to a negative 3. Now, as I've alluded to, one of those two numbers is not going to work. So let's start with the 9, since just because it's the bigger number, why not? Okay? So I'm going to say the square root of 2 times 9 plus 31 plus 9 equals 2. Okay, so 2 times 9 is 18. 18 plus 31 is going to be the square root of 49. 9 equals 2, and 7 plus 9 equals 2. Again, we're really only concerned about the principal value. That's why I'm not saying plus minus 7. So 7 plus 9 is going to be 16, which is not equal to 2. So this 9 that we got is a good solution as far as the quadratic here is concerned, but not as far as the radical equation itself. Okay, so real quick, let's just walk through the last one, just to make sure that the 3 works also. So the square root of 2 times negative 3 plus 31 plus the negative 3 equals 2. So negative 2, or 2 times negative 3 is negative 6. Negative 6 plus 31 is going to be the square root of 5 minus 3 equals 2. 5 minus 3 equals 2, and that is true. 2 equals 2. So in this case, the x is equal to 9. That is the extraneous solution. So the only really good solution for the radical is the -3. Okay. So this is going to conclude this particular video. The algebra that we're seeing here is a little bit shaky, but as long as you're taking your time and showing your steps or showing your work step by step, you should be in good shape. If you have any questions, again, please make sure you bring them to me in class, and I'll see you soon.